All right, just going to work with some more word problems. Keep working with those. Going to work with those tomorrow too. Tomorrow I'll get some more complicated ones, a little trickier. Today's will be a little trickier than we did the other day. Not like horrible though. We'll save the really hard ones for tomorrow. All right, so we got to start with a square checkerboard. It has 4 sides that are each 18 inches long. How far will a checker travel if it starts from one corner of the board and travels across the board? All right, so first thing, what shape we got to start with? Square, draw a square. Label your square sides, right? And then we're going diagonal. So if we got a square, mine's maybe not perfect as usual. That's fine. We label it. You don't have to label all 4 sides necessarily. And then you go diagonal. My diagonal is not even perfect corner to corner. All right, Aubrey, what you got? Nevaeh? Yeah, if we're about the rounding. You got your square root of 18 squared plus 18 squared. And what that gives you is the 25.4, and then we got a 5 after it, and then all our other stuff. So remember, when we're looking to round, we're looking at the next digit to the right. So we're looking at that 5. Anything 5 or higher, we're rounding up. So we'd have 25.5 for that one. All right, if you were thinking 25.4, you did the work right. You're getting it. Multiple choice wouldn't be a problem. If it's one where you have to type it in and it specifically says to round, though, and they do that occasionally, you got to be able to do that. Okay? Any questions on that? Not so bad, right? When you see diagonal, what part of the triangle is it talking about for diagonal? Hypotenuse, yeah. So anytime you see diagonal in the problem, it's talking about the hypotenuse. So if we're trying to find the diagonal like this one, we're finding the hypotenuse. All right, a little bit different. What's this asking for? Perimeter. So this one's not really like kind of a word problem, but it's just one of those that's a little bit different. So go ahead, try to find the perimeter. Zah, what you got? No. Aubrey? 30. Oh, sorry. All right, so we're missing one side of the triangle, right? So we got to find the hypotenuse. You got square root of 5 squared plus 12 squared. What that does is that gives us 13. We're asking for the perimeter, right? So how would we find perimeter? Add up all the sides. 13 plus 12 is 25. 25 plus 5 gives us that 30. Any questions on that? All right, so let's make it a little different. Molly wants to put a fence around an area. The fence will follow the diagram of the triangle shown below. About how much fencing does Molly need? All right, so 43 is going to be our answer. We got to find that missing side. Any of these Pythagorean theorem problems, that's pretty much what we got to do. We got to find that missing side. All right, so we got square root squared minus 10 squared. 18 was the hypotenuse, so we're looking for the other leg. You get 14.96 and all that other stuff. 6 makes us round up. So when you round 9 up, that's going to put it to a 0. We got to carry that 1 over. So that gives us about 15. All right, so it's about the whole number. Yo, what's she doing?
She's trying to area.
Nope, what's she doing? She's trying to put a fence around it. Hey, where's fencing go? Around it. Fence doesn't fill it in, right? So the fence goes around. So what are we trying to find? The perimeter. So this is just a different way of asking for the perimeter, okay? Every so often you'll see a problem like that where it asks about like a fence or something. And that's what you're looking for then on those fence problems is the perimeter. So you got the 10 plus 18 plus 15, and it gives you the 43. Got to be careful with our rounding, though. All right, any questions on that? All right, so let's make it a little more complicated. All right, perimeters around the outside. So what you're looking for is that, okay? That height doesn't matter for the actual perimeter. You do have to use it, though, to get the perimeter. If you do this right, you should get a whole number on this one. Whole number. All right, so look. We got a rectangle and a triangle, right? So if this is 15 at the bottom of the rectangle, what's this on the top of the rectangle? 15. We're still missing that side right there. All right, so that 5 comes across as well, doesn't it? Now, 5's not part of the perimeter because it's on the inside of the shape, but we need to use that 5 to get our hypotenuse on that triangle. So we do square root of 5 squared plus 12 squared, and that's our 13. And then we're adding up all the sides around the outside. So 15 plus 5 is 20, plus 15 is 35, plus 13 is 48, plus 12 is 60, and that's our answer. All right, so like I said, they sometimes, right? But that's how problems like that work. You'll a lot of times see ones like that where they got like a triangle in another shape, or sometimes even like a triangle. Pythagorean theorem to get the numbers we need. Any questions on that? So I'll do this one. This unit, we got to do some Pythagorean theorem. We got square root of 5 squared minus 3 squared. That's 4. All right, what is it asking for? Area. Who remembers from 6th grade math how to find the area of a triangle? Yeah, base times height divided by 2. All right, so we got base times height divided by 2. Sometimes you see it as 1/2 base times height. I like dividing by 2 better than multiplying by 1/2. It's the same thing, though. All right, what's the base and what's the height for this triangle? Yeah, the base and the height are going to be the legs. So when we have an area problem with Pythagorean theorem, that's what we're looking at, the legs, okay? The hypotenuse doesn't matter for area. 3 times 4 divided by 2. 3 times 4 is 12. Divided by 2 gives us 6. Any questions on that? So if they ask you for area, remember area base times height by 2 for a triangle. All right, so this is a little more complicated, isn't it? Yeah, base times height divided by 2. All right. What's the base of this triangle? $21. All right, the base of the triangle is 21, all the way across. All right, we got a 15, we got a 6, so that makes our base 21. Everybody go with that part. All right, do we have the height? No. We're missing the height. It is right here. So to get the height, we have to do Pythagorean theorem, okay? There's a triangle on the left. You know, if we went with that, right? That's a right triangle we could use. Or we could use the one on the right. Okay? Everybody with me on that? All right. Teams 1, 2, and 3, do the purple triangle. 4, 5, 6, do the blue triangle. Purple on the left, blue is on the right. Find the height of the purple. Eight. Someone for blue side. What we get? 8. Y'all, that's the way it should work. Right? I mean, it's not 88. I just wrote it twice because it's the same for each triangle, right? We only need to use one of them because it's the same height. I just wanted to show y'all we're getting the same number either way, right? So now we got to find our area. We got the height, or we already had the base, was 21. Height is 8. Going to divide by 2. So, Caden, what you got? 84 is correct. Everybody good on that? Little bit more complicated than the last one, right? Y'all, there is a very good chance you see a triangle like this. All right, sometimes it will have the height missing. Sometimes it might have the base missing, okay? So if it gave you 8 as your height and had both these numbers missing, you'd have to do Pythagorean Theorem twice to get each of those numbers and then find the area. So they can get a little tricky sometimes. So one last one. It's maybe a little bit on the tricky side, just a little extra to it. We got a 16-foot ladder leaning against the house and is 3 feet from the edge of the roof. We need to find the height of the house, including the roof. So we're looking for that height, whole thing. Just go ahead, just give it a try, see what you get. No, this one you'll get a little bit of a decimal. All right, so we got 3 pieces we got to add. We got to get the green piece, purple, and red to get the total height for the roof. So the red and the purple already got numbers for them. So we're going to have 8 plus 3 plus whatever our green section is. So to get the green section, y'all, we got a right triangle there. The hypotenuse is the ladder. Ladder's our hypotenuse. Square root of 16 squared minus 6 squared. The ladder's the diagonal. Ladder's the hypotenuse here. So that's 14.8. Everybody good on that part? Then it's just a matter of adding up all 3 of those. So 8 plus 3 is 11. 11 plus 14.8 gives me 25.8.